Okay, so before I begin, remember, Ben here, he's going to hit Hamming code like 3B, 1B. It's his own mathematical or, well, computer engineering two-phase to, can I get the breadboard to go everywhere that 3B, 1B wants to buy it in their computer set to get him to do all of the same programming level. So I don't need it to do all the tricks. I just need it to be able to handle, what is it, Java and a few other things, C++, or whatever. But once I get it in the computer chip and it can handle that information from the pump pins to do whatever, that's hammering out Hamming code like picking apart Bernoulli at the chessboard. I figure I muscled them out. The Z-coin possession.
Now, perhaps you've heard of error correcting memory or error correction in communications. Well, in this video, I'm going to show you how that
How many
works.
codes?
I'm going to
How
walk
much
through
line
building
code a
a
minute?
circuit
How much good
that
code
allows
a
us
line
to
a minute?
encode a message as a series of bits and have that message encoded in such a way that if one of those bits gets flipped, and here we can flip a bit off or flip a bit on, but the message is encoded in such a way that even if we do that, even if we flip one bit,
And the inherent undertone of the conversation,
decode the message
still
back to whatever
ones
the
and
original
zeros
was
on an offset lineup. What do you got? He's running
And I'll explain how that
to
works, but if you want a more
build
thorough and
this.
truly
Yes.
beautiful
The other
explanation
day,
of
he
the
was
math
putting the
behind
8 on
my
here,
friend
the
Grant over at
16,
channel
and another
3 Blue
chip
1 Brown made a
for
video
the
walking through that
figuring
that
out
you should
Hello
really check
World.
out.
I was watching that one last
Well, to get a
night.
sense of how error correction is even
And
possible
doing the
at all,
error
think
correction
of the
on
absolute
the
most
bits and
simple
bytes.
case, which is error correction
So you
of
do
a
it
single bit.
mathematically. What
We
it
could just
means
store a
in
copy
the
of
two-phase,
bit,
the
and
stone
that
mill,
would let us
is
detect errors,
sigma,
because if we store a 0,
or
0,
yeah, well, sigma
read 1, 0,
I,
well, then we know
right?
there was
Sigma
an error
equals
here.
I,
If
and
we
then we're
store
going to start
1,
putting
1,
that
and
in a
read 1,
position
0, we
over
also
it
know there's an
by
error. But either way,
computer
we're
chip
reading 1,
of
0. We don't
infinity
know, from that
sigma
what the original bit was
I1
supposed
or
to be,
whatever
whether it was a 0 or a
left
1.
hand right hand
So if we
rule
want to be able to
will
automatically
do
correct the
binary.
error and not
Binary
just
already
detect
does
it,
it because
well, we
if
could
it's
store
speaking
a
a
second
language
copy
that
of
works,
the
it
bit.
becomes gravity.
And that way,
Whatever you
if
got to
we
do to
read
follow
1,
that
0,
code's
0,
process is
we
going to
would
be
know, okay, well, if we take
quadrant,
kind of 2 out of 3
geometry.
here, if we're
It's going
assuming
to
that
be
errors are
on
rare
or
enough,
off,
we probably
hot or
only ever have
cold,
one at a
it gets
time,
compressed, it
then reading
opens
something
up.
like 1, 0, 0
And
probably
why
means
it
the original
chose
bit was
is
supposed
to
to
go
be
1
0.
1 1
If we
1
read
1
something
has
like 1,
code
0,
sequence.
1,
What if it's going this
well
way?
then,
Well,
same
it's
thing,
hot and
2 out of
cold,
3,
firstly.
figure, well, it's probably,
Z
probably
theory,
supposed to be a 1.
zenith this way,
That's a
zenith
really
prime
basic error correction,
at the
but
end
it's not at
value.
all efficient to store 3 copies of every bit.
But that's why it makes this
So
choice.
can we
1
do
1
better?
1, which one goes 0?
Well, it turns out
Front
we can
one,
do a
the
lot
end
better,
one,
but
or
we have
this
to think
one?
about these
Which
extra
one
bits not as
by the
copies
system
of the
has
original bit,
some kind of
but
system
as
on
parity
here?
checks.
0 being the first. If
So
it was
what
1,
is
then
a
this was
parity
this way,
check?
and this would
Well, I've
output
got some other videos on
probably
parity
upside
checks,
down.
but basically,
Or
if you have a bunch
you
of
would get
binary
something
data,
simple like
you can add
0,
a bit that will ensure that
10,
the data has an even
and
number of
100.
ones. So here we've got 1, 2, 3, 4.
Because that
1,
was
0.
actually
So
0
in this case,
0
it already
1
has an
with the
even number of
offset. That would
ones.
make
So we
sense
could add a parity
because
bit of 0.
they'd be ones and
But if it had
zeros,
an
hot
odd
or
number of ones,
cold.
we could add a 1 there.
And so once you hit a 5
Total
on there, it
always has
starts
an
to
even
slide
number of
over or
ones.
something. Every 1, 2,
That
3,
lets
4,
us detect
5
an
is it
error
in
because if any
position,
single
change
bit
it over
changes,
to
then
a
it won't have
X
an even
OR
number of
gate
ones anymore, and we'll know
and
that
get
there
it
was
to
an error.
revalue inside that
So this is
system. So
obviously very efficient
in
in terms
here,
of
the
detecting
XOR
a
gate
single bit error because
is
you
the
can have as
simplest
many bits
system
as you
before
like,
you start
and
putting
only a single
together
parity
a
bit to
chip
detect
that
that,
has
and that
multiple
will detect,
systems on it,
detect
where you
any
might be
single
in
bit
just
error.
trying out the
But it won't let
breadboard
us correct it.
phases
So
comparatively
another way
to
to think about this
a
scheme
small
where we're
design
storing
or
3
anything
copies
else we'll
of
use
the
a
bit
store
is to
design
actually
like
think
that
of
to
storing
do
2
when they get
parity checks for
into
the bit,
Tim Cook's cell phone,
because that's actually going to let us extend it to more
job
bits.
cell phone, whatever,
But in this
whoever,
case, it looks
same
the same,
thing.
right? Because with a 1-bit message plus a parity bit, you either have
Tim Cook,
no
what do they got
ones
in
this
comments?
case,
Definitely a name. The
or
trigger's
you have
turned
2
over
ones
to the
in this
ones and
case.
zeros in a
And
keyword
those
search.
are really the only 2 options with 2 bits to have an even number of
It might
ones.
just not
And then, of
understand
course,
that
the
that's what it's
second
doing, so when
parity
you hit
bit
the
here is
reset
just
button,
a
it doesn't
second check.
understand the what
So the nice
code
thing
from
about thinking about
yesterday
these as
when it
parity
was
bits
doing
is it
that.
lets us extend this a
Alright, so
little
hold on. We'll pause that out. Because these two things are kind of relative. We'll put 2 of them up. Should be my history from last night. Good stuff. This is how many qubits, matter of fact. That's a fun one. Here we go. What I'm looking for specifically, Ben, between the next step that you're going to make, I think I got you on pause.
simple clock and data protocol
Yes.
like this.
You're
I've
gonna
showed you
hit
in
this little
previous
reset
videos how it's
button,
pretty straightforward to
and it's going to
build
screw
a
this up
circuit
real good because
that
this
computes
is the
parity bit.
transmitting
So we just have our clock and data
XGate
coming in here, and we just have an
into
XOR
all
gate
that,
and a D flip-flop,
doing
and out the other side
what
comes
we're doing.
a parity bit that we can use to validate that our message was received correctly, or at least that certain types of errors didn't occur when we received our message.
So back to what
But
we
of
were
course, the
talking
parity
about.
bit is not very robust. There's all sorts of errors that
what
might
I'm
be
showing here is
injected
we've
into
got
our
data
message
bit, and we
that a
have
parity
our
bit
Get
won't
another one
catch.
going.
And I'm just showing here.
And
Get
it's
the
like
8 bits,
one
the
of
basics of the
easy
8-bit
to
clock
inject an error
running.
like
The
that, and you'll see
first
the parity
hook up
bit
the
is
one
still
with zero.
matched on both sides, so we haven't actually caught this error with the parity bit.
combination.
So in other
You
videos, I showed you things
are
like
working at
checksums
terminal
and CRCs that are much
225.
better
If
at catching
and then same
you
all
get
sorts
good
of
enough,
types
it will
of
be
common errors
because
that
you,
occur
in the stone mill, you were like,
But
oh,
the
I want to know
downside
what's
of
going
those
in
is
this
they're
thing
much more
right
complex. So CRC, as we saw
Get you
in the
in
last
the
video,
shot.